Hello, good morning or good afternoon, everybody. It is really a pity that I couldn't come to the conference. I'm still wearing a metallic fixator around my leg, so it wasn't possible to pass the security control at the airports. Nonetheless, I hope that you have a very successful conference. So my topic is about the science behind the organic movement. My talk will give an overview on global organic research. Then I will give a short definition of organic research. Then I will talk about the importance of organic research for the future development of organic. I will say something about yield gaps, and I will develop a little bit the strategy for sustainability and the role of organic farming. And finally, I will end by some thoughts about innovation. If we look at the current annual spendings for organic research, I estimated that in Europe, the spending for research, specific research on organic farming systems, is about 180 million US dollars. On the other hand, in the United States and in Canada, there is about 60 million US dollars, so it's an important place for organic farming research. Latin America is less important with 20 million. Asia also about 20 million US dollars. And rather poor compared to the land area is Australia. And of course, research is quite scarce in Africa. So looking at the future trends in research, we see that in the EU and in other European countries, it is a strong growth to be expected in organic farming. Also in Asia, some countries like India, like China, like South Korea, really invest into research because they see their chances for the environment, but also for exports. On Australia, it is probably decreasing. And in Africa, it's moderately increasing, and in Latin America, I expect that the funding won't grow in the next years. So in total, we see that about 0.6 to maybe 1% of all research funding, the private and the public ones, are spent on specific problems of organic farming. What we see is that we have quite a contradictory situation, that looking at which system really contribute to improve sustainability and resilience in agriculture, these are really the complex system where we have an increasing complexity of measures taken by the farmers. This goes from GMO, improved technologies, minimum tillage, GMO crops, and so on, to integrated production, low input agriculture, low external input, sustainable agriculture, organic farming, and then more complex organic farming systems like organic successional agroforestry system. And if we talk about ecological or eco-functional intensification, the last four systems can be really named as ecological intensification system. On the other hand, if we look at research funding, most of the money goes into the very simplified attempts to become more sustainable and for instance into organic successional agroforest systems, which would be extremely important for the tropical zones. There almost no money is spent for research. So it is a contradiction between the research funding and the promise of our policymaker to make agriculture in general more sustainable. What exactly is organic agriculture research? It is difficult to divide research into specific organic and specific non-organic research. So one might say that developing specific and unique organic finish techniques, so those techniques which are really crucial to organic to make it perfect, this is one definition of organic research. But then also comparing organic and conventional and integrated farming systems is also part of organic research. Then increasing knowledge about ecosystem services and agroecology is also part of organic agriculture research. And then, of course, developing materials, tools, techniques and equipment common for all farming systems. In a way, organic farming systems also profit from that. And that's the reason why it is always very difficult to get exact figures on research activities in different countries. We looked at these 4 categories in Switzerland, and we saw that, for instance, category A, that this is about 10% of total funding. A and B together is about 20%, and ABC is about 50% of all research funding, public research funding in Switzerland. So it's always important to understand what we are talking about. We talk a lot, especially in Europe, about what Organic 3.0 means. What is the future development of organic? And for me, the most important definition is that making organic fit for the future means that organic wants to grow out of the niche and becomes mainstream. Another definition or another categoristics is that we have to push innovation in organic agriculture, social, ecological and technological innovation. Then we intend to foster best sustainable practice in organic agriculture. Then we want to improve transparency and consumer trust in organic farming. And also one goal of Organic 3.0 is to better cooperate with other social and sustainability movements, for instance, agroecology, fair trade. So say farewell to the old tradition that organic farming is splendid isolation. If we look at the meaning and the importance of science for this Organic 3.0 goals, we see that science plays a role for all the different goals of Organic 3.0. So organic is crucial for developing organic farming of tomorrow, and especially push innovation, of course, is really addressing activities and more activities of science. If we look at the societal trends in agriculture and food system, and this is also very true for organic farming, we see that we have a lot of contradicting tendency. For instance, on the one hand, we have farmer tradition, tacit knowledge. A lot of organic farmers, for instance, say this is the way forward. Others say it is progress, it is modernity, so it's not about tradition. A lot of organic farmers have a regional approach, have a small scale approach, and others think big, think global. The business has become global. A lot of people talk about natural methods of production, about nature. Others talk about technique. We need to have more technique. And for many people, organic farming is about emotion, and for others, it's about science. And I think that organic farming shouldn't let it squeezed in these contradictions. We should well play with these challenges. For instance, for me, a picture of the future is organic farming is nature with high tech. This could be a definition. So using the best of different worlds. If we look at the leading places for organic farming research, I would say, I'm not a very modest guy, that Switzerland is really the leading place for organic research. We see that the market growth is one reason for that, the important dependency. The dependency from imports, the size of the farms, which is quite small, then the weak economic competitiveness of Swiss farmers compared to other European farmers, the strong preference of consumers for animal welfare, quality and health, but also environmental policy and the commitment of retailers. Also, Denmark is extremely leading in science. For instance, the preference of consumer, I think, is an important reason. The environmental policy, but also for Denmark specifically, export opportunities to Germany, to other European countries, and also the retailers play an important role there. Germany, on the other hand, they also have a strong market growth. They have a preference of the consumer for organic food. They also strongly depend on imports. They want to push the domestic production, of course, and environmental policy and animal welfare. Animal welfare is a very hot topic in Germany. And maybe already the fourth in line might be Canada. You might answer that better than I can. And at the very end of the line, we see the UK and the United States, where research plays a minor role. And for me, this is strange because both countries, and especially US, have a very fast-growing organic market. And what we can identify is a certain organic phobia of the scientific community and also of the policymakers against the term organic. This is seen as some kind of voodoo science and not a real science, serious science. What we know from research is the strengths and the weaknesses of organic agriculture. We have a lot of literature comparing different farming systems. So what can be said on a scientific basis is that multifunctionality is the most characteristic feature of organic agriculture, but also diversity, biodiversity, but also farm diversity, lower negative environmental impacts characterize organic, stable soil, which are less prone to erosion, carbon sequestration, a good nutrient use efficiency and adaptation to climate change, a resilience in general. These are the positive, the strengths of organic farming. And if we look at the weaknesses, we see that there are still many deficits on the social side, for instance, labor condition, but also on the animal welfare side, and also on the quality of horticulture crops, for instance. There we still need some improvements, but also quality of cereals and so on. A weakness is for sure the research gap, and a weakness is the yield gap. Unfortunately, within the organic movement, this is a little bit the taboo. But I like to talk about the yield gap because I think this is an important argument against organic farming. And if you want to know more about that, I published a summarizing paper of all these aspects in the proceedings of the Nutrition Society in 2014. So looking at the yield gaps calculated by different meta-analysis, and this is about all crops in a rotation, always comparing conventional and organic farming, we see that the yield gap is from -9 to -25. So I would say yield gaps in general under intensive agriculture conditions is between 20 and 25%. We have exception, for instance, soybean. We see many organic fields which have the same yield for organic and conventional soybean, but for most of the crops we have a considerable yield gap. And what is also very relevant, if looking at the yields of organic farms and organic fields, we see that it is quite a flat bell curve. So we have very low yielding, a lot of very low yielding fields, and also some very high yielding fields. And for instance, if we compare only two long-term research trials, the DOC trial in Switzerland, there over a 7-year crop rotation over several decades, the yield deficit is exactly 18%. So this is more or less a little bit above the mean value of all this meta-analysis. And for instance, if we look at a long-term trial of the University of Kiel in Schleswig-Holstein, where the condition for cereal growing is the best in Europe, we see that the yields of the entire crop rotation is only 50% inorganic compared to conventional one. So this is really also to be considered, that the spread is very high, meaning that can also influence strongly food security. In a way, one might say yields are not relevant, and indeed they are not relevant if we stick to the opinion that organic is a niche market strategy. On the other hand, if we say we can successfully implement a sufficiency strategy, meaning that we can avoid wastes, field losses, food waste, field losses, and we can change in a considerable way the diet of the human population, then it is also not relevant to talk about yields, because in that case we would have enough food. But this element of temperance, introducing the element of temperance into our food system, has been proven as not possible so far, and in literature we don't see really feasible strategies to strongly avoid food waste, to strongly avoid field losses, and to change the diet of human beings. And that's why, as long as we don't have a sufficiency strategy, we have to talk about yields in organic farming as well. And basically it's very clear that organic has lower yields, because if we look at how yields are built up, we see that from natural soil fertility, the transformation of natural resources is the same for organic and conventional system, but then the transformation of short and long acting and anthropogenous measures like fertilizers, like fossil fuel, like plant protection agents, like soil tillage, like crop rotation, manure, and so on, is quite higher in conventional farming, of course, because the input is much higher. And for me, it's clear that organic is also not yielding at the same level as conventional farming system. On the other hand, we can look also at outcome. So the outcome as acquired soil fertility, meaning the natural soil fertility plus the positive or negative impact of the farmer, this is then different. It is higher in organic farming systems and it's lower in conventional farming systems. On the other hand, yields are much higher where the effect of the inputs is strong. And the third development to look at is our ecosystem services, and there, of course, the more input, the more intensity we have, the lower ecosystem services are. So understanding that concept of input, of outcome, it is clear that organic farming cannot yield as much as conventional systems. And we also have many studies about the explanation of the yield gap. So weed control is one, nutrient availability is one, pests and diseases are one. So in a way it's clear that these are the limiting factors of yields, especially in organic systems. In the context of a EU project with a lot of partners from different European countries called OCANet Arable, Organic Knowledge Network Arable Crops, we identified the state of the art of research results and also best farm practices to answer the question, which are the most important levers to increase organic yields. And we also identified on the basis of these scientific results the reason why organic farming has a deficit in yields. We talked about a niche strategy. Yields are not important if organic is a pure niche strategy. But if we want to mainstream sustainable food system, we have different strategies. So increase productivity and yield stability of organic agriculture is one strategy, because on the ecological side it's already very good, and on the productivity side it has some weaknesses. But we can also go the other way around by strongly reducing the environmental impacts of integrated agriculture. Make integrated agriculture less polluting and keep the productivity of it. And the third solution could be to develop completely new and less codified than organic agroecological food system. So in a way to develop a new system close to organic but not so much codified with so many bands. This could be a third strategy. For me and for our institute, it's clear that we are not the ones pushing the niche strategy, we are the ones pushing the mainstreaming of sustainability ones. And as I already said, for that we need innovation. We need more innovation in organic farming as well. And talking about innovation, social innovation is important, ecological innovation is important, technical or technological innovation is important. This has been so during the entire history of agriculture, meaning during the last 10,000 years. It's always the same, and it's true for organic farming as well. Social innovation, a lot of people talk about that. We don't need any technologies. We can organize ourselves in a different way. For instance, the community-supported agriculture movement becomes very important. It is especially spread in the United States, in Germany, but also in other countries. So consumers, farmers working together, and in that case, the profit of a farmer or a farm community is usually higher, and the prices for the consumer are lower. In a way, this is a clever strategy for many farms, but it's also a strategy for a minority of organic farms. Another social innovation is to use and to identify the traditional, the tacit knowledge of farmers and also veterinarians in our case here. That's what we did when we look at how farmers and old veterinarians treat the animals, for instance, against mastitis and other diseases. And we conducted about 300 interviews with farmers and vets, and we identified, according to their home recipes, about 100 different plant species which are used on farm, and we could describe more than 1,000 home or farm recipes, and now it is put on the internet and it is available for other farmers to follow this old, partly forgotten strategy. But other more scientific recovering of old knowledge is that we use bioactive fodder plants for the control of gastrointestinal nematodes of ruminants. For instance, sainfoin is very good, but also chicory. In the northern country, in Europe, chicory is more used, and in middle Europe, it is sainfoin which is used. And these are very good plants. They can be fed to animals, and they have an active deworming effect. And with all the knowledge we recovered again and we spread among the farmers, we have now in Switzerland several farmer groups who produce together, for instance, sainfoin, and who produce hay, and who sell it to their colleagues, and they feed it. So it is a joint strategy of reactivating old knowledge and using it in a sound, scientific way. Talking about ecological innovation, it is clear that we always mean, for instance, soil fertility, the potential of fertile soil to increase productivity. A lot of research is done, for instance, about plant growth promoting rhizobacteria. This is a group of bacteria living in the soil and having very intensive interaction with the roots of the soil, which is especially interesting. Modern science talks about the microbiome of the soil. In a way, the digestion organ of the soil and the interaction with the plant. At the moment, a lot of research is done on that, and even breeding programs, plant breeding programs, look at this interaction to see whether a plant can make better profit from that interaction. mycorrhiza, of course, belong to that. And we see that the farmer has many ways of influencing this interaction by soil tillage, crop rotation, manuring, organic and green, but also by xenobiotics. Another example of ecological innovation is also a feeble example. In the last 5, 6, 7 years, we tested a lot of plant extracts. Till now we have tested about 3,000 different plant extracts, botanicals, and have looked at whether they have an active compound with a fungicidal effect. And the research has been so far very successful because we already identified 5 completely new botanicals never described in literature, and one of it, the extract of a tree, is already patented, larixene, and we hope that out of this plant extract we can develop completely new fungicides, botanicals, so that copper, which plays an important role in Europe, can be completely replaced. This is one example of an application in a vineyard. Then coming to more technological innovation, with this picture you can immediately understand that technology has a huge potential for organic farming. So on the right side, it is in a way a stupid use of agricultural technology for industrial monocrops. This might be a picture from the United States or from Canada. And then the other example of a beautiful organic farm in Argentina, La Laguna Bianca, the combination of contour and strip farming, which enables an intelligent agricultural technology by precision farming. And you immediately understand you can use modern technology to bring a new diversity, new interactions into a landscape, and also to improve the quality of the landscape. It is really a beauty. It's not a monocrop system. So in a way, I think that modern technology, robots, precision farming and so on, have a huge potential to bring back diversity into agriculture and to serve the purposes of organic farming. So as the second last slide, I want to introduce very shortly the TIPI, the Technology Innovation Platform of IFAM. This is a global research network of scientists, farmers, and farmer associations. And you can see that thankfully Andy Hammermeister is in the board. And we really are very ambitious to push hard organic farming and concepts of organic farming, and also funding for organic farming worldwide, and to bring organic farming research into the discussion of international organizations. You find more information on Organic Research Net. Coming to my conclusion, I think the role of science, of the scientific community, is going to play a more important role for driving organic agriculture forward than it has played in the past. The size of the funding is unfortunately contrary to the complexity and the sustainability of farming systems. So complex farming systems need much more research than simple ones. And the leading countries in organic research, they see a considerable potential in organic farming, and that's why they support organic farming. And the potential they see is for their consumers, for their farmers, but also for the society and the environment. I think that the way forward is not isolated innovation, for instance, a technological innovation, but it's a comprehensive culture of innovation using all three pillars in a balanced way. And the potentials for research and for progress in organic farming, in my opinion, are considerable, and that's why it's worth to invest money into research activities. Thanks a lot for your attention.